Okay, so here's that question in my open math, and some things that we want to notice is I know that this is a sine graph. I know it's got an amplitude of 5. I know the period is here. Let me get my board going. Oh, heck, I got all these cords tangled up. Just a minute. I gotta make the jump and buy a cordless tablet, Wacom tablet. Um, I'm being cheap. Let's see. I'm gonna annotate. It's also like the fourth version of Wacom tablets I've purchased over the years. I don't know if I want to buy another one. But anyways, so I digress. So I've got the sine x. I was asking about the period. So I know normally sine has a period of 2 pi, right? So we know, whoops, no, I don't want a line. I want a pencil. So we know normal period is 2 pi, and to find the period, we are going to divide by the b number. That tells me the period for this sine graph is pi over 3. That means it repeats every pi over 3, so it's going to shrink up a lot. So, I see you got the first one right because you knew how to divide by 6. I'm going to show you how you can get all these solutions. Okay, it's a similar, it is the same sign value, and we'll get you through there. Okay, so what I did first off, let's talk about the answers. So I went out to Desmos and I graphed. Let's see if I can get this to do it. I graphed 5 sine 6x on one equation, and I graphed y equals 3 because that's the other side of the equation, right? On one and here's what I'm seeing. I'm seeing that all these squiggles. Now I know from the work I just did that the period is pi over 3. So I'm going to tweak my window here to go from, I don't know, what do we say? A negative pi over 3, negative pi, actually, let's see. Yeah, let's go negative pi over 3. That way it'll be one cycle. Pi divided by 3. And then, I mean, it'll be a couple of cycles, right? Because I'm going 2 periods. A positive pi over 3. We can always tweak it later. And then, yeah, that looks good. Oh, and let's do the step. Let's do the step. Let's see. What's a fourth of pi over 3? Pi over 12? Divided by 12. That way we'll be able to see it a little better. And I guess we won't, that's a good amount. So you see how this is the solution, that's the solution you got. Then how do we get that next solution? And for that matter, what if they ask me to find 3 solutions? Well, this one, see how this is going up and coming back down. There's one cycle, and here's the start of the next cycle. This is pi over 3 apart. And the fourth solution, that'd be pi over 3 apart, those two. So how do we come up with all those? Well, if you look at my work here that I posted here, let me come up and um, where's it going to be a good way to look at that? Let's see, can I zoom this in? Let's see. Here we go. So my analysis is what I did is I solved that equation. So I divided both sides of this equation by 5. And then I know that all trig ratios are positive in quadrant 1, and only the sine and cosecant trig ratios are positive in quadrant 2. So I knew my answer was going to be in these 2 quadrants. And so I said, here's the 3 over 5, and there's the 3 over 5. So I know that this theta answer here is going to be arcsine of 3 over 5, and I got that answer there. And this angle here, this one that I wrote in pen, we get that by doing pi minus that answer, right? Because this reference angle here, let me get a pointer going. This angle here, this reference angle is the same as that angle. So in order to find this angle, I did the pi minus the 0.63 number. Okay, that's the second angle. But now that's just for sine x, right? We're not dealing with so far I've been dealt with a 6x. So what I did, and this is usually what I do when I do these kind of questions, I'll write that initial value plus 2 pi k, just like I'm finding multiple answers, right? We've done that. And that's equal to 6x. And then I divided everything by 6. I divided this by 6, and I divided that period by 6. So that gave me that 0.01725 that you got, plus 1 period, or actually I can say however many periods. Okay, and that's why when I let me come back to Desmos here. Do you see how this is here? Let me uncheck this one. Uncheck this one. That's why I said, okay, so to get this answer, that's that 0.017. Then if I added pi over 3, that's that one. If I needed another answer like that on the same position, see, that would be this answer plus pi over 3, or that original answer plus 2 pi over 3. Okay, so I can get as many answers as I need once I get that set up. And then to get that second set of solutions, so this is like the one that's in quadrant 1, right? So the second set of solutions will be like it's in quadrant 2. Now it's not really in quadrant 2 because that's just not in quadrant 2. But the period it's changed, right? Relatively speaking. So that's that second solution, right? The number that, what was it, 1.6. It was the 2.5 2.496, which came from pi minus that reference angle, right? It's that divided by 6 plus the pi over 3. Okay, so you see what I did there? So this open math question is only asking for this solution, because you're only looking for the yeah, I'm only looking for the 2 solutions. But if I wanted 3 solutions, I would have to take this number and add pi over 3 to it. If I was looking for first 4 solutions, I would have to take that number and add pi over 3 to it. Okay, and that's honestly how I set these things up. I hope that helps. You know, go into the textbook and look at some of the ones in there if you need some more practice. I am going to ask you a question like this on the exam, and you need to be able to show me the analysis to it, not just do the graph. Okay, the graph will get you 2 points. It'll get you 40% of that. I usually do, if it's a 5-point question, I'll give you two of the 5. But to get the full credit, you need to show the analysis. You'll need to be able to do this kind of thinking in calculus. So that's why I have you do it. Okay, well, hopefully this helps.